Hey guys, it's Miss Wilson back again with another one in my DJ Khaled voice. But seriously, let's go ahead and do Unit 2, Lesson 7, Writing Equations of Polynomial Functions. All right, so let's start with some vocabulary key terms. And so we're going to first define factored form. And factored form is the form of a polynomial that has been broken down into a product of its factors. So if you're wondering what that means, I have an example for you right here. So P of x is equal to A times x minus R1, R1 being your first root, x minus R2, R2 being your second root, x minus R3, your third root, and so forth, depending on the degree of the polynomial. What's new is that A in the front. And what that A is, it's basically just the leading coefficient. That can stretch, compress, or flip the graph. So basically, that A determines if the graph is stretched, if the graph is compressed, or if the graph is flipped. And you'll see different examples of A and how it impacts the graph, and we'll be talking about that a lot. So we're going to pretty much use the same polynomial throughout the rest of our notes to look at the different ways to write equations and how to determine what the equation is of a polynomial just by using it, not just by looking at it on a graph, identifying the factors, and then converting it back to the standard form that we're used to seeing our polynomials written in, okay? So, using factored form, write a possible polynomial equation for a function that has zeros at -3, -1, and 2. You can use the graph to the right as a guide for the functions in behavior. Well, this graph starts at the bottom and it goes to the top, okay? We notice that the ends are in two different directions. So it's not like it's both facing up or both facing down. So that means that we have an odd positive, okay? So that means that this graph is going to be an odd degree. And we can guess by looking just at the roots of this particular graph that this is a cubic graph. So this graph has 3 roots or 3 solutions or 3 x-intercepts, okay? So I'm going to go ahead and write the equation in factored form of this graph. So I would have g of x, because that's the name of my graph, is equal to A. We don't know what A is yet, but I do know that A is positive. X plus 3, X plus 1, and X minus 2. All right, so that's the factored form for this graph. All right, so now we got a little bit more information about this graph. So it says that there is something compressing or expanding the graph of the function g of x below. Let's use the known point of -4 and -9 to determine the value of a. So the first step is going to be to write the equation of the graph in factored form. Well, we did that already. Okay, so this is the point that we're using, -4, -9. And I'm going to go ahead and I'm going to rewrite it again. So I have g of x is equal to a x plus 3, x plus 1, and x minus 2. All right. Again, here are our zeros. Okay, the next step is to substitute the values of the known point into the equation to find the value of a. So I know that my x is equal to -4, and I know that my f of x is equal to -9. So I'm going to go ahead and rewrite my equation again, but this time, instead of then using g of x, that's going to be -9. I still don't know a, but x is -4 plus 3. X is -4 plus 1, and x is going to be -4 minus 2. Okay, so now step 3 says solve for a. So I'm going to go ahead and I'm going to take my -9, and that equals a, because we still haven't found a. But -4 plus 3 is going to give me -1. -4 plus 1 is going to give me -3. And -4 minus 2 is going to give me -6. I could simplify this even further, where I'll have -9 is equal to a times -1 times -3 is +3 times -6 is going to give me -18. I want to get a by itself, so that means I'm going to divide both sides by -18. This cancels out, and so I'm left with a is equal to +1/2. Okay, because -9 over -18 would simplify down to +1/2. All right, so from the first page, we had the original equation, which was g of x is equal to, and instead of then using a, now we can use 1/2 x plus 3, x plus 1, and x minus 2. All right, so we substituted the a that we found, and the a that we found was 1/2, and we went ahead and we plugged it back into the equation that we had in factored form. Well, now we want to convert it from factor form back into standard form using either the area model or the distributive property. So I'm going to show you guys both ways. I personally like the area model. I find that it's quicker, but some others may like the distributive property way for doing binomial multiplication. All right. So the first thing I'm going to do is I'm going to take two of these binomials and I'm going to multiply them together. So I'm going to pick x plus 3 and I'm going to pick x plus 1. And basically you just cross multiply. So I have x times x, and x times x gives me x squared. I have 3 times x, and 3 times x gives me 3x. Then I have 1 times x, that's going to give me 1x. And now I have 1 times 3, 3 times 1, or 1 times 3, and that gives me 3. So from this, I'm going to have x squared, 3x plus 1x is 4x, and then I'm just left with a 3. So you basically are just going to combine like terms, all right? So now I'm going to take my now quadratic x squared plus 4x plus 3, and I'm going to multiply that by my remaining binomial, which is x minus 2. So now I'm going to do the same thing again. So x squared times x is x cubed. Then I have 4x times x is 4x squared. I hope you guys can't hear my snoring baby because he's laying on my lap snoring right now. 3 times x is 3x. All right, so now let's multiply it by the -2. So x squared times -2 is -2x squared. Then we have 4x times -2 is -8x. And then finally, we have +3 and -2, and that's going to give me -6. So again, I'm going to combine like terms. So I have x cubed, and then I have negative 4x squared plus, negative 2x squared plus 4x squared. Well, that's going to give me positive 2x squared. Negative 8x times 3x is going to give me negative 5x. And then I'm left with a negative 6. But I can't forget, I still have my a value, which is 1/2. Well, that means that every value inside of this parenthesis, each one of these are now going to be half of what it currently is, because when you multiply by something by a half, it's like the same thing as dividing it by 2. So this x cubed is going to get a 1/2 in front of it. So now it's going to be 1/2 x cubed. Well, what's half of 2x squared? Well, half of 2x squared would be 1x squared. So I can just put x squared. My negative 5x, well, I'm just going to go ahead and put 5 over 2x. And then what's half of negative 6? Well, that's going to leave me with negative 3. And so here is my g of x equation written in standard form. 1/2 x cubed plus x squared minus 5 over 2x minus 3. Okay? All right, so now let's look at distributive property. All right? I'm going to go ahead and just draw a line here. And let's get started with the distributive property. So I'm going to start again with my equation. So my equation is 1/2 times x plus 3, x plus 1, x minus 2. And to make it easier, it'll probably be best to just use FOIL for these last two binomials. I'm just choosing to use these two. So that'll give me x squared. That'll give me a positive 1x. That'll give me a negative 2x. And that'll give me a negative 2. And for those of you who don't know, FOIL means to multiply the first terms, the outer terms, the inner terms, and the last terms together. And then you combine like terms to simplify. So this would simplify down to x squared minus 1x minus 2. Okay? And generally you don't put the 1x, but I'm just going to leave the 1x only because I'm going to use the distributive property and it makes it a little easier. All right, so now that I have that, what I'm going to go ahead and do is I'm going to put some parentheses around this, and I'm going to bring down my x plus 3. And so what I have to do is take each of these terms from the x plus 3, and they're going to multiply into each of these. So I'm going to take x times x squared. That's going to give me x cubed. I'm going to take x times negative 1x, and that's going to give me negative 1x squared. I'm going to take x times negative 2, and that's going to give me negative 2x. But I'm not done. I also have to do the 3. So I'm going to have 3 to x squared. So that's going to give me 3x squared. I'm going to have 3 to negative 1. So that's going to give me negative 3x. And then I'm going to have 3 to negative 2. And that's going to give me negative 6. Now I can combine like terms. So I will have x cubed. Then my negative 1x squared and my 3x squared, well, those two would combine to positive 2x squared. My negative 2x and my negative 3x would combine to negative 5x. And then I'm just left with negative 6. But can't forget about that a. So I now have to distribute this 1/2 to each of them. So 1/2 is going to be distributed to each term in the cubic. All right. So that's going to give me 1/2 x cubed. And then half of 2x squared would be x squared. half of negative 5x would be 5 over 2x. And then half of negative 6 would be negative 3. And again, this is my g of x equals, and I'm done. So I got the same answer for a area model, converting from factor to standard form, as I did with distributive property, okay? All right, so I hope these notes were helpful for you. And as always, you can always ask Mr. Klawan or I any questions you may have about your notes. All right, see you soon.